Hello everyone, welcome back to my channel. In today's video, I'm going to take out this cutting machine and check whether it still works properly. However, even after turning the power switch on several times, the machine still doesn't work. Next, I press the battery check button, but none of the indicator lights turn on. This suggests that the battery pack may have a problem or could be completely out of power. So, I'm going to remove the battery and inspect it to find out exactly what's causing the issue. First, I'm going to use the original charger to check whether this battery can still receive power. However, when I connect the battery to the charger, the indicator light does not change color like it normally should, suggesting that the charging process is not working properly. To make sure, I use a pair of electrical clips connected to a small light bulb. When I clip them onto the charger output terminals, the bulb lights up immediately, showing that the charger is still working normally and providing stable power output. I remove and reconnect it several times. Next, I check the battery directly using a multimeter. When I place the two probes onto the battery terminals, the meter only displays zeros on the screen. This indicates that the battery either has no output voltage left or may have an internal failure. I'm going to mark this battery with a piece of tape labeled with an X so it can be easily identified during the repair process. After that, I begin taking the battery apart for a closer inspection. First, I use a screwdriver to remove the screws from the battery casing. Once the cover is opened, I can clearly see all the internal components inside the battery pack. Next, I use a multimeter to check the electrical connections and wiring inside the battery. The multimeter still only shows zeros on the display, indicating that the battery pack still shows no sign of working again. So before moving on to deeper testing, I'll start by cleaning the internal components first. I use a toothbrush to scrub away dust and dirt stuck on the components and electrical contact points. This cleaning step helps make the inspection and repair process easier while also reducing the chance of dirt affecting the electrical conductivity of the connections. I'm also going to clean the outer battery casing to remove the dirt and dust that has built up over time. After that, I move on to cleaning the internal circuit board. I use WD-40 to clean the circuit board. First, I spray a small amount into the bottle cap to make the process easier to control. Then, I dip a cotton swab into the liquid and gently scrub different areas of the board. This helps remove dust, oxidation, and improves the electrical contact between the components. In the next step, I spray a small amount of WD-40 directly into the battery contact slots. After that, I fold a small piece of sandpaper and gently rub inside the contact terminals to clean the metal surfaces and remove any rust or oxidation built up inside. Next, I prepare 2 electrical wires, 2 paper clips, and 2 alligator clips to begin the battery recovery process. These parts will be used to create a temporary connection between the power source and the battery terminals during the reactivation process. First, I start with the blue wire. I strip off the insulation layer at the end of the wire to expose the copper core inside. Then, I split the copper strands into 2 smaller branches and twist them together with a paper clip to create a contact point. At the other end of the wire, I attach an alligator clip. After that, I use pliers to clamp the end tightly so the wire stays firmly connected to the clip during use. Next, I repeat the same steps with the red wire to complete the connection setup for testing and reviving the battery. Next, I'm going to use a 12V car battery as a temporary power source for the battery pack. The car battery already has plus and dash markings to identify the positive and negative terminals. Before making any connections, I carefully check the positive and negative terminals to avoid reversing the polarity during the process. First, I attach the paper clip from the red wire to the negative terminal of the battery pack. The alligator clip on the other end of the red wire is connected to the positive terminal of the car battery. Next, I connect the remaining blue wire to complete the temporary power supply setup for the battery pack. This setup creates a temporary activation current to supply power back into the battery pack. The process may help wake up the internal protection circuit or restore operation to batteries that have dropped to an extremely low voltage state. After about 15 minutes, I disconnect all of the temporary connection components from the battery pack. Next, I begin reassembling the battery casing back into its original form. I place all the screws back into their original positions, then use a screwdriver to tighten them securely and lock the battery housing firmly in place. Finally, I'm going to recharge the battery pack. First, I plug the charger into the power outlet. Next, I connect the battery to the charger, and the indicator light immediately turns red, showing that the battery has started charging again. After about 20 minutes, the indicator changes to green. I press the power check button and all 4 battery bars light up, confirming that the battery pack is working normally again, which means the battery is now fully charged. Next, I attach the battery back onto the cutting machine and power it on. As soon as I press the switch, the machine instantly spins up at high speed and runs strongly, just like before. Now it's time for a real-world test. I start the cutting machine and begin cutting through a piece of metal. The cutting blade spins smoothly, the cuts are clean, and the machine keeps running steadily without losing power. This shows that the revived battery is once again capable of supplying stable power to the tool. And just like that, a battery that seemed completely dead is now working properly again. If you enjoyed this video, don't forget to leave a like and subscribe to support the channel. Thanks for watching, and I'll see you again in the next DIY project.